This question says a person has 180 feet of fencing in which to enclose a three-sided garden adjacent to a building. What dimension should be used to maximize the area of the garden? Hint, let width be X and length be Y. So 180 feet of fencing to build a garden like this. So if we add X plus Y plus X, that should equal 180. So let's start with that. Length, excuse me, width plus length plus width has to equal 180. 2X plus Y has to equal 180. Now what's the area of this garden? Area is, of course, length times width. So area will be X times Y. So area here is X times Y, but I only need to have one variable to work with. So here's the key idea. I have to solve for Y. I'm going to subtract 2X from both sides here. And what do I get? Y equals 180 minus 2X. So now my area is X times Y. My area function will be X times 180 minus 2X. And this is what we want to maximize. So let's do that. Area is X times 180 minus 2X. X times 180 is 180X minus X times 2X is 2X squared. I'm going to write this in the usual form. Area is negative 2X squared plus 180X plus 0. Remember, our usual form for a quadratic function is f of x is little a x squared plus little b x plus c, and the vertex occurs where? The vertex occurs at x equals negative b over 2a. So in this problem, what do we have? We have a, or our function, I'll call it f of x here just so we don't confuse the two sets of a's. F of x is little a x squared plus little b x plus c. So little a is negative 2, little b is 180, little c is 0. Not that I need that. But my vertex is negative b over 2a. So again, what do we have here? We have a is negative 2. We have b is 180. So x is negative b over 2a. So it's negative 180 over 2 times negative 2. X is negative 180 over negative 4, which gives us 45. So the vertex occurs at 45. The vertex will be the maximum. Why is that? How do I know that? If a is negative, the parabola is heading downwards. So the max will occur at x equals 45. What is the maximum area? Well, I've got to plug 45 into that equation. So I have a of x is 180x minus 2x squared, or minus 2x squared plus 180x. Plugging in 45, a of 45 is negative 2 times 45 squared plus 180 times 45. What's that going to give me? Negative 2 times 45 squared plus 180 times 45 gives me 4,050. So how do we conclude this? What do we say? The maximum area is 4,050 square feet when x was the width, when the width is 45, when width is 45. Now, how do we find out what the length is? Well, if you remember on the other page, we said y was 180 minus 2x. We just said that x was 45. So y is 180 minus 2 times 45. Y is 180 minus 90. Y is 90 and the length is 90. When width is 45 feet and length is 90 feet. Let's take a look at the graph and see if indeed that's the case. So this is the function we're trying to optimize. And we believe that when x is 45, the maximum area, the y value is the maximum area. So understand when we're looking at our graph, x and y is not width and length. X and y is width and area. Make sure you keep track of your variables. So let me go ahead and jump to Desmos. And I will write it as a of x, just to relieve some of the confusion, is x times 180 minus 2x. And I need a big window. Remember, we thought it happened at 45. So as I adjust my window, I better go beyond 45, like to twice that, to 90. And my y value, I think it has the maximum area of 4,050. So I better go to at least 5,000 or 6,000. And there we go. So does it appear as if that's our maximum value? It sure does. So the x of 45 and the y of 4,050 appears to be the vertex. You also could have found that maximum value using the graphing calculator's max finder.